Yeah, with my face. Hello, class. It's the voice and the video. Do you see my face? I'm sorry? No. I'm going to disappear. I'm like, okay, bye. So when I upload it on YouTube, you get to see the whole video and my face. 24 hours a day, 7 days a week. So, okay, so quickly review. So question number 1, basically, when conducting a z-test, I just basically said that when the sample is near the mean, this is the region of acceptance, and this is the region of rejection right here. Then, when conducting a z-test, okay, so when you get a sample that falls here, you get the likelihood of these samples falling at the extremes is low and unlikely, so that's why you reject the null hypothesis when the sample is obtaining of such a sample is low and unlikely. Okay, moving on. Recording good. So what are the critical z-score values for conducting a hypothesis test for the following? Null hypothesis, population mean equals 200. Null hypothesis does not equal 200. And alpha 0.06. Hint, the extreme rejection regions left and right of the distribution must equal to the alpha, which is in this case 0.06, or you can divide it by 2, so 1 side. So this side has to be 0.03. This side has to be 0.03. So if you add them together, it's 0.06. So I gave you a link to how to get the z-scores for that. And most of you got it right. I'm guessing most of you, I mean, I don't know. If I were you, I would just plug in the values. I don't know if that's what you did. So Ilse just confirmed that. Okay, so anybody else wants to confess that's what you did? It's okay to confess, it's fine. Okay, so I take that as a maybe. All right, good. All right, go. So that's the answer because that's 0.03 on this side, 0.03 on that side with that z-score. Plus and minus 1 point, sorry about that, 88. Questions on this one? When conducting a one-sample z-test hypothesis test, we must first assume no difference exists between the specified population's means. So that's a basic assumption of any hypothesis test that you're going to conduct, that you always assume there's no difference. Whatever you're comparing, either a sample against the population, or it could be, in today's lecture, 2 samples. We'll talk about it later. Whatever you're comparing, you always assume that they're equal. That's how you start it off. So that's the null hypothesis. You expect that they're going to be equal. So there's no difference, in other words. So that's why. Questions on this one? If you were to perform a one-sample z hypothesis test and the value of alpha is the extreme regions of rejection, is changed from 0.1 to 0.05, the greater the value of z is required to reject the null hypothesis. So let me show you an example. So the regions of rejection, let's say for point 10, so it's going to be 0.05 here, 0.05, 0.05. So this region is basically 0.05, or about 5%. But if I were to change it to 0.05, okay, so that's okay, so you add these two together, you get 0.10. So let me show you another distribution with 0.05 total. So it's less on each, the rejection region is less. So the critical lines go further away from the mean, like here. And so this is going to be 0.025, 0.025, if you add them together, equals 0.05. All right. Well, here I'm going to make an alpha with a rejection of 0.05, which is less. Values go further away. So here, this one, you go further away, less space. Such as 0.025, 0.025, they add together. You are a third grade teacher and you wanted to know how your classroom students perform compared to other third grade students in the state. You performed a one sample Z hypothesis test and found out that they score statistically significant above average at the 0.05 level. If this was the outcome for this hypothesis test, it will also be significant at the 0.1 level. Okay, so this is key, 0.05 level. So I already said that 0.95 level, the critical values or the regions of rejections is this much, for example. But here, it will also be significant at the 0.10 level. Since 0.10 is larger, the regions of rejections is larger as well. So these are more here. Okay. So if it's significant at this level, more likelihood that the sample will land in a more limit compared to which is less. So the question and say significant at the 0.10 level, I definitively say it will also be significant at the 0.05 level. If it was significant at the 0.05 level, can I also say it will be at the 0.05 level, which is less. Okay, so so because here, oh, was that a happy face? Oh yeah. Okay. I was testing out my pen. That's what I do. That's what I did during my spring break. Okay. Who's laughing at that? Okay. All right. So let me show that again. All right. There you go. Okay. All right. So anytime I want to get a laugh from you, I'll just show this. All right. All right. I'm sorry?
What's the story behind it? Cocktails.
That's after class. I'll explain after class. Just... You missed it? Oh, okay. Oh, I'll show you after. I'll show you after class. Okay. So. Let's just say this is point 10 level. Okay, so this region plus this region. So I get a sample that falls right here. Yeah, each side is 0.05. I mean, yeah, 0.05. Okay. You get a sample. Understand this is the projection, all right? So you get a sample that falls right here. Now, I change my criteria to 0.05, which is less region of rejection. So total region of rejection. So it's going to be, let's say now it's going to be here. And then this amount is going to be 0.025, 0.025. All right, so now it's left. Okay, so that represents the amount of region of rejection. Larger than so your alpha is, the more rejection you have. 2.05. So critical values went further away from the mean, all the way over here. So the region of rejection have been revised now to what happened? It went further away. There's only my region of rejection got smaller. The sample lands here. Now saying that now that K6.05 is right here, do I accept it or reject the hypothesis? So that's basically what I was trying to say with my first question. So at the 0.05 level, yes, back 0.05, reject the hypothesis, and then you still significantly in at the 0.01 level. If I were to change it and say, let's say if I have 0.1, would it still be significant at the 0.05? The answer is ultimately no. Because it was significant at the 0.10 level, 0.1 level, I could definitively say it will also be when it's like this, but not the other way around. Questions on that? All right. When alpha, L regions of rejection, is assigned a relatively low value, there's a lower risk of making a type 1 error. Okay, remember not last week, 2 weeks ago, the magical dices? It was fun, right? So we had to, so if you were to, say, accuse somebody with those magical dices, but they really don't have magical dices, that's making a type 1 error. Ultimately, the further away your critical values or your lower your rejection, regions of rejection, the lower the risk of making a type 1 error. So, in other words, remember when we're throwing dices and so you roll the dices and you get a pair of ones 3 times. And then you say, okay, if you get a pair of ones 3 times, I would declare that those are magical dices. Other people may say, no. If you throw them and then you get a pair of ones 10 times, those are magical dices. So, for some people, they may say, if you roll your pair of dices and you get ones, let's say twice, that's probably, the likelihood of happening is probably around here. And so if you're saying that if you get, a pair of ones twice when you roll it, then the likelihood is probably around here. And then if that's your criteria to declare magical dices, then that's where you have your critical values. But you may say, wait a second, I don't want to say just twice. I want to say, to really definitively know these are dices that are magical, you need to do it 20 times. Get a pair of ones 20 times, and I believe you. Those are truly magical. So in that case, to represent your criteria, if you want 20 pairs of ones of your dices, it should be like this level. The likelihood of getting ones 20 times in a row is really rare, and that's your criteria. And so that's where you have your critical limits, like at this level. But who plays the lottery? Everybody plays the lottery. Have you won the lottery? Obviously. Yeah, you can say yes, but you just try to pretend no because you know people talk to you. Anybody who wins the lottery is good to not let anybody know about it. Anyway, okay, so people play the lottery all the time, right? But most people lose. But if they won, let's say, how do you know they're cheating? Okay, let's say you're a detective and you want to figure out if the person who's playing the lottery cheats. What is criteria? If they won it one time, is that enough or no? Or they need to win it more times? Okay. So let's say if they won it 2 times in a row, is that enough? 3 times in a row? I mean, what is the criteria? I just want to make sense. Like, at what point do you think this person is cheating? 5 times? Is that anybody else? Twice? Okay. Let's say 3 times, right? 3 times. So if you look at, let's say, your criteria on 1, so let's just say, for example, that's the whole criteria. So you have people winning 1 time, and then they claim they're cheaters. But they're not cheaters. They won the lottery. Like anybody else. So you just, if that person won the lottery and you tell them, hey, you cheated, you're making a type 1 error. Right? Because you're claiming that person cheated, but that person didn't really cheat. And then you say, okay, let me increase that criteria. Let me say 3 times. You have to win it 3 times in a row, and then I can definitively tell you, I'll say, or make the claim that I can cheat. So when you say 3 times, you're moving these lines further away. So far away that anybody, that it's very unlikely that a regular person, should win 3 times in a row. At least it's very likely that that person won it the regular way or the legal way, and then you can claim that person, but that person just did it legally. And you're in the risk of making a type 1 error, claiming that you well. So the further away you go, the lower the risk of you claiming that person cheated. In playing the lottery. So the further away you go, the lower the risk of you making a type 1 error. Questions on that? Okay, this is funny. Okay, so Jennifer rolled her pair of dice 10 times and calculated the mean value of her dice's rolls, which was 10. Linda suspects that and claims that Jennifer has magical dices. However, Jennifer really has regular dices. Linda's claim is an example of type 1 error. All right, type 1 error is you make a claim or you accuse somebody or you make a claim something, like there's a difference, or whatever case may be, but they're really not guilty of that, or there's really no difference. It's making the claim that there's a statistical significant difference, but really there's no difference. Questions on that? All right, here we go, another one. Jennifer rolled her pair of dice 10 times and calculated the mean value of her dice's rolls, which was 10. Linda claims that Jennifer has regular dices. However, Jennifer really has magical dices. Linda's claim is an example of what? Yeah, okay. Yes. Type 2 error. So type 2 error is when magical dices. That person difference, but really the opposite of error. So type 2 is basically, if you want to see it in another way, it's like declaring somebody innocent, but that person is really good. That's another way of seeing it too. Or making the claim that there is no statistical significant difference, but in reality, that's the definition. All right. And then I tell you to define null hypothesis, alternative hypothesis, and critical values. So if you've done all these, you should have some sense of that. Null hypothesis is basically making the claim there's no difference. This population value mean equals to this sample value, or this population mean value is the same. Alternative basically saying that there is a difference, not equal. Critical values is those lines that I indicated, your criteria as to what will convince you, or what is the criteria that you would determine if there's a difference or no difference. And then a critical thinking question. All right, so there you go. Any questions on this? Yes. Oh, I see. Okay. Let's see. Give me a moment. Oh, so this one? Okay, let's see. No internet. What's going on? Okay. So here we go. All right, so we want to get the area of both sides. So you want the area of both sides. So it's going to be negative and plus 1.88. Or these other values. So you want to get left and right equal area. And then you type in the dash first, negative 1.88. And then that equals to 0.06. Okay, good. Okay, so there you go. So just to let you know, I've tried it before. I was having trouble. I wasn't putting the negative. They're like, what's going on? The professor was like, pulling it down. So no, so what you have to do is put the negative the numbers. Questions? All right. Okay, we're going to move on to lecture. Yes.
Is that the same thing that we did for the assignment yesterday?
Similar, but no. Yesterday's different. I mean, the assignment for number 4?
Yeah.
It's different calculator. For that one, you had to put the population mean, the sample mean, standard deviation of the mean, and then it'll give you the.
But in the sample S, it wasn't really the same. So we had to take in error.
Mhm.
Wrong number.
Oh, no, he actually had to copy and paste the values. I remember now. So you can see me after class. We can look into that. Hopefully you can. Just making noises. Just kidding. All right, here we go. Lecture time. Yes. All right, quiz 7 review, assignment number 4 review. Who had fun with assignment number 4? Raise your hand. All right, everybody, good. Okay, now who had fun with the assignment number 4? Don't raise your hand. All right, you see, almost everybody had fun with that. Almost everybody. You didn't have fun apparently. Okay, sorry to hear that. All right, so basically, the cool thing about this assignment is that all of these information, like the sample, came from you. So we're going to analyze you compared to the people from the United States as a whole. So we're gonna compare ourselves, this class, with all the U.S. people in the United States. So it's going to be pretty cool. So one sample t-test compares the mean of your sample data to known value. For example, you might want to know your sample mean compares to the population mean. All right, so here we go. So how many minutes per day on average do you spend on social media, Facebook, Twitter? As an example, it could also be Instagram. All right, so by the way, SPSS is going to be slightly different. For those of you who did an SPSS, will be slightly different than those who did it with Excel or the online calculator. So it's just the way it is. So, but it's very similar. So I did this on SPSS, and I also did it on Excel. So, all right, based on this, the average was 57 minutes per week. Oh, no, I'm sorry, per day. Okay, so 57 minutes per day on social media. Wow, that's pretty good. Okay. Either that or somebody was not being truthful, but it's okay. That's pretty good as a mean. Compared to the national average, 135 minutes per day. Oh, wow, that's good. You guys, so this was significant. Significant, okay, sorry. Okay. So how do we know it's significant? It was less than, the chances of we getting the sample mean was less than 0.05. So right here, this value is less than 0.05. So that be basically when we see that is significant. Also, if you did the online calculator, it tells you right there too. So compared to the national average, you statistically significantly spend less time on social media. Congratulations. Okay. Yes. So what I'm saying here, less than everything else is so low that it gives 0.000. More than 0.05. So I did the analysis on SPSS, and the difference between 135 minutes, 135 minutes per day of this class, no different. That the likelihood of me getting the mean for this population is very low. Very low. Therefore, 0.05, and I would declare this as online calculator. Tells you to. No, I'm telling you now. figuring it out, I mean, it'll just analysis to you. So I'll give you a quick trick here. Or even the online calculator, less than 0.05. The most scientific use. Less than this value. So just take note of it. On like here is SPSS, here is my calculator. So ask yourself, is this less than 0.05? And then I would say less than 0.05. Therefore, is questions? All right, so we're going to spend less time on social media than congratulations on that. All right, so moving on to the how do you report it? So let me see, what do I report? Okay, so I would just write here something like minutes per day on social. Good to see the video. It's going to be pretty interesting because you only can see my stylus. All right. Oh God. Put on your 3D goggles. I'm going to like, ha ha. All right. Minutes per day on social media. All right. From EDFN4520 students in the general US population. So which one should I use? Significant results or non-significant results? Very good. So, yeah, you can like, yeah, if you're not going to use it, I mean, if you left it, it's okay. I won't deduct or give you a penalty. So degrees of freedom, depending on which one you use, if you use the SPSS, it's going to be 21. For some reason, I got a couple more people on the SPSS file, not on purpose. I don't know what happened. I think because when I downloaded it, I got 2 more responses from the SPSS file, and then I got 19 responses for the Excel file. I think it was the timing. So, I'm sorry? Oh, okay. Okay. Well, don't give up, all right? Keep on trucking. You're almost there. 5 more weeks. 5 more weeks. All right. Okay. Moving on. So the degrees of freedom, if you use it, says there were 22 responses, subtract 1. So 22 subtract 1 is 21. If you use SPSS, all right. If you use the Excel, we had a total of 19 people. Oh, was it 20? Oh, okay. So sorry. You see, I'm testing you. I'm testing you. Yeah, you guys passed the test. Good job. It's 20. 20 subtract 1. 19. Yes. All right. Good. 19, and then your t-value, if you're using, well, it depends. Which one do you prefer to me to follow, the online calculator or the SPSS? Online calculator? All right. Okay. All right. Oh, yeah. Oh, yeah, Ilse. I'm sorry. Ilse. Sorry. Ilse. I noticed you did the online calculator, so you have trouble with SPSS. Okay, unfortunately. Next time, right? All right. Well, let's use the online calculator. So that t-value is this. Negative 7.6. P-value, you could just You could either put this or you could just put 0.00. It's fine. That's fine. The sample mean, if you use Excel, it should be this. 58.05. Standard deviation of the sample, 4510. It's right here. And then was significantly, was it greater or lower? Then the population mean of, it should be 135. All right, that's it. Questions on this? No questions. Wait, look, one at a time. I can't answer both of your questions at a time. Take turns. I'm just kidding.
We were trying to do it through SPSS, and I don't have those numbers.
Oh yeah. So there's SPSS is different. So SPSS is going to be 20 degrees of freedom. Is going to be 21. T value is right here, negative 8.84, negative 8.4. And then the p-value is the same. Gosh, where am I going? What am I doing? So, do you see what I'm? Do you see where I'm getting my values? For what? 5.75? SPSS for this one? This question? Double check your work. Oh, maybe I should double check my work. Then again, we use the online calculator, so it's kind of close. So are we talking about the t-value, this one right here? Say your value again. Do you have it in front of you? So, all right, give me 20 seconds. Let me check your work. Oh, I see what you did. Oh, I know. I know the problem. Yeah. There's a little field on the bottom. You put 135 there. You have to compare it with the national average. Okay, so we've got the results. It's all good. Any other questions? Okay. So don't do this one. Okay, how many hours per day on average do you spend on sleeping? Okay, we got a national average. Well, national average is 6.5 average a day of sleeping. All right. And then based on your survey responses, we got 6.16. All right, good. You're getting enough sleep. I'm glad. Keep it going. Sleep is very good for you. So, based on this, all right. So ask you a question. Probability of you getting the sample compared to the population national average. My calculator is ask yourself something. Is this value or this value less than 0.05? Less than 0.05. All right. So what does that mean? If it's not less than 0.05, not declare it significant. You may want to take note of that. So always look at this value, or you start to look at this value. I mean, the only calculator pretty much tells you because it's more than 0.05. So when it's more than 0.05, so you may ask the question, what does this mean? What does this mean? So it's basically saying that the probability of you getting a sample is about 31%. That draw the distribution. And these are critical values. The sample it fell here. Closer to the that's basically what your sample based on the responses in class average mean. So the region are separate. So we don't declare that our values are significant. All right, so I'm going to report this. Hours per day. So hours per day on sleeping. Hours per day sleeping. And then which one should I use? Significant results or non-significant results? Very good. So if you use online calculator, was it it was 20, right? 20 total responses, I think. Okay, so it'll be 19. Degrees of freedom is 19. So it's the number of sample size minus 1. So we had 20 responses in the Excel sheet, minus 1, 19. T-value is this, negative 1.2. Sorry. Your p-value, 0.23. I messed up, sorry. This should go here. Nobody corrected me. What's going on? And then sample mean, I put it there, 6.07. Standard deviation, 1.56. Was not, I guess you could say greater, or was not significantly, was it lower? Let's see. Okay, was not significantly lower because this is the national average. This is your average. So they're almost the same. And the population mean is 6.5. Okay, so what does this tell us? So they're not different than the national average. At least not different than the national average. In terms of how many hours of sleep you get. Any questions on this? All right, moving on. If you work, how many hours per week on average do you work? Okay. So the national average is 19. We're talking about students, by the way. They hardly work. What's going on? Yeah, these are students. So. And your average is 30. You all work full time? Is that what's going on? Yeah. I know Ilse works full time. I'm gonna pick on Ilse today. So, Kenneth, do you work full time as well? All right. Who does not work? Okay, that's okay. You don't have to say. But it sounds like you. I mean, based on this sample average, it sounds like it appears that most of you work. All right. So the question is the difference between the national average and then our average, are they statistically significant? So I think so.
Different?
That determination. Focus your attention on this. Ask yourself a question. Less than 0.05.
Yes.
Less than 0.05. So, the amount of hours you work is significantly different than national average. So, I mean, that's very telling. So, you need to report that. And the way to report it is, let me see, hours per week working. And then these are significant. So, and then degrees of freedom, 20 people, -1, 19. T-value 6.5. P-value, you use either one. I'll say 0.00. The sample mean. Sample means right here, 31.85. Sorry. Standard deviation, 8.79. So all these came from Excel, by the way, if you followed what I did. For which one? P-value? Oh, yeah, that's okay. Okay, you got it from the outline calculator, right? That's okay. I mean, when you start reporting this, 3 decimal places is fine. Unless you work for NASA, be my guest. All right, so should I put greater or lower? You guys work more than the national average, or you work less than national average? Overwhelming. And then the national average is 19. All right, so there you go. You reported it. That's how you report your findings using APA style. But it's good to do this because not only it helps you learn how to report it, but also when you read studies and journal articles about studies, that's how they report it as well. Questions on this? All right, no questions. All right, this is a good one too. I like this one, kind of. How many hours per week on average do you spend on studying? All right, so the national average is 19.3. All right, The sample here is how much? So I'm curious. Why do you think you spend less time studying as compared to the national average? Anybody else wants to say another reason? I figured that makes sense. So you work less than the national, I mean, you work more than national average in terms of work, hours per, job work wise, and you study less than national average. But I think it's because you work more. Is that fair to say? All right. So I need to report this. So was this significant? Yes or no?
Yes.
Why do you say that? You missed the point. Very good. 0.05. So this is less than 0.05.
Same as the value.
Oh, if it's at 0.05, you see, you have to make so that's a good question. So what you do is from the very beginning, you have to say either P has to be less or equal to 0.05. Most of the time it's less. So if it's at 0.05, it's not less, therefore you accept it. You don't reject it because it's at 0.05. But it depends on what your criteria is. If you say less than 0.05 and it's at 0.05, it's not less than, it's at 0.05. Alrighty, so here you want to report your findings. So hours studying per week. Hours studying per week. And then significant or non-significant results template. Significant? All right, good. So here, degrees of freedom is the same, 19. T-value is going to be negative 5.4, negative 5.4. P-value, I could just put 0.00. If you did the whole numbers, that's fine. Sample mean, 9.1. Standard deviation, 8.31. Was this greater or lower? Lower. And then population mean is this, 19.3. All right, that's how you report it. Any questions? Okay, how many hours per week on average do you spend on commuting or driving? Oh, yes, question. Only if I'm in it. Any other requests? After class, I'm willing to take pictures with the class too. If you want to, if you want to take a picture. Like, here's my cool professor. Just kidding. I'm kidding. I'm not like that. Well, yeah. Well, I try to be cool, but I don't know if I'm cool. So. All right, moving along. How many hours per week on average do you spend on commuting? All right, so the national average. This is from students. All right, it's 4 hours, 4.3 per week. I know. Who works in Culver City? You work in Culver City too? Oh, you want a carpool with you'd say? I can set up a carpool. All right. All right, so hey, you want to trade numbers after the class? That's fine. All right. All right. So how many hours per week on average do you spend on commuting or driving? So our national average per week, I know, 4.35. So small.
Is that here?
No, that's national average. Most people dorm. Most college students dorm, I think. I think that's what's going on. Yeah. So we're very different from everybody. Okay. All right. So for this class, basically you spend about 14 hours per week. That's the average. So the question is, was this significantly different from the national average? Why do you say that? Okay, I heard something. Go ahead. All right, so you're going to report it now.
So can we always just tell them to pee?
No, not always. Not always, because it goes through a formula through standard deviations and stuff. So yeah, if you eyeball it, but sometimes it could be a very small difference. I mean, let's say it's like 13 hours versus 14. I mean, yeah, if you eyeball it, that's a small difference. You may think it's a small difference, but when the standard deviation is so small, that small difference is huge. Especially, let's say, for example, like, sorry to go to this area, but blood labs. Let's say if you're getting a physical and they take blood out of you and you say, okay, the difference is 0.1. You're like, 0.1 of what? And like, it can make a difference. Like, it depends on whatever they're measuring. Depends on the units. So anyway, it takes all that into consideration. Yeah, I see your point. I mean, you could just eyeball it sometimes. Yeah, like 100 versus 4. And that's a for example. Of course, yes. So let me report this. Hours per week commuting. Commuting or driving. So it's going to be significant. So degrees of freedom is 19. T-value 3.00. P-value 0.007. Sample mean 14.6. Standard deviation 15.25. Okay, was this significantly greater or lower? You guys drive more than the national average or less? Greater. Okay, greater. And then the population mean is 4.35. Sorry. Okay, there we go. I'm done with my assignment. Any questions? If we're going to take more pictures, I have to be in it. She's like, oh, he's joking. Okay, so I'm joking, by the way. You can take pictures. It's fine. I don't have to be in. Any questions on this? Was it clear? Did you learn something about yourselves? There we go. You guys are awesome. No, I really commend all of you. It's really challenging to be in school, working full time and going to school. It's really hard. I mean, I want to give you all kudos. I mean, it's not. I know, and then this is a hard class too. You know, I try my best to make it easy, but I just want to commend you all. So keep at it. All right, you're almost there. 5 more weeks. Everybody's like, just move on.
We're all passing, right? That's what you're trying to tell us?
It's okay. I'll cry after class. Single simple confidence intervals. All right, who's with me? Come on, another topic. All right. Okay, I'm gonna give you. Okay, so we're gonna have fun. We're gonna have fun, a little bit fun today. All right. So hold on before you get distracted with Kim Kardashian. So I'm gonna give you 10 trivia questions. All right, and I'm gonna ask you to give me so these questions is asking for a numerical answer or a date. But instead of giving me something specific, I want you to give me a range. All right? I want you to give me a range that you're 95% confident that you're going to get it right. Okay, so I'm going to ask you a question, and then it's going to ask you about, like, and the response has to be some kind of date or something, or numerical value. And then I want you, instead of that single date, I want you to give me a range that you're 95% confident is going to be correct. Okay, so I'll give an example. What is Kim Kardashian's age? Don't look it up even, okay? But give me, like, if you don't know her exact age, give me a range that you're 95% confident that her age, her true age, will fall in between your range that you're going to give me. So who wants to volunteer? All right, so, well, hold on. Ooh, wait, hold on. Hey, one at a time, you guys. One at a time. So I'm going to start from my left to my right, if you don't mind. Go ahead. 30 to 35. Okay, you say, what do you? 35 to 40. Anybody else? Anybody else? Give me a range. One more person. 30 to 40. Okay, okay, one more range. Give me another range. 35 to 40? All right, let's see what's the answer. How do you know? Hold on. Oh, okay. Okay, so you're right. Her age is 38. So you guys all got it right. That's good. I think all of you got it right? I think so. Okay, good. So good. No, that's good. That's the whole point. So, I'm sorry, where did I have the answer? It's right there, like right there. Oh, you didn't. I'm doing magic. It doesn't know. So she's 38. Uh-huh. I think she's still young, right? Yeah? No? Okay. All right, moving along. All right, take out a sheet of paper. All right, so these are your 10 questions. Okay, so I want you to, for each of these questions, okay, so in what year did the last episode of the following shows aired? So give me a range. Give me a range. So Vampire Diaries, I think that's the episode, right? So give me, okay, so last date, give me a range of dates that you're 95% confident you're going to be right. All right, so last episode aired for The Office, Prison Break, and then in what year did the first episode of the following shows aired? Criminal Minds, Grey's Anatomy, Big Bang Theory. So I want ranges. And then in what year was the following movies first released? A Walk to Remember, 50 First Dates, Back to the Future, and Aladdin. Oh.
I know. Most current or?
Thank you. Wow, somebody's a fan. Oh, thank you. Thank you for correcting me. All right. So take a sheet of paper, email and the ranges, and swap with somebody else. Sorry.